Okay, so welcome all from my side to New Stars of Data. My name is Jan, I'm 29 years old. I come from Slovenia. As said, I'm data engineer. I started my career when I was 21, I think. I started as a Click developer, but early I shifted to the Microsoft data stack. Started with Power BI, then Azure stuff, and now for the past 2 or 3 years, Microsoft Fabric. Besides my professional career, I am a husband and soon to be a father to a daughter. So this will be happening in October. So really looking forward to that. And beside that, I am a huge basketball fan, and my whole demo project for this presentation is built on top of the NBA games data. So you can find me on LinkedIn, so feel free to connect. All the materials from today's session will be posted on my GitHub account, and you can also contact me via email. Mentor for this session today is Marisol, my ex-colleague, and I'm really thankful to her, for her time and for the opportunity to be speaking today. So let's move forward. In today's session, I will present various deployment strategies for transitioning between stages in Microsoft Fabric. Specifically, we'll look at how to shift your connection endpoints, semantic model sources between development and production stage. There are already many excellent sessions and blog posts available on deployment strategies. It's one of the most frequently discussed topics in the community, but it's also, on the other hand, not an easy question to answer what approach is the best, because we don't have one recipe that we should follow regarding deployment. And basically, most conversations and deployment strategies tend to end with the classic phrase, "It depends." So my goal for today is to challenge that mindset a bit. I'll show you 3 deployment strategies that you can use with clear guidance on when and how to apply them. So let's go quickly through the agenda. 1 second. So agenda for today is, first we'll go through Git integration. So when discussing deployment scenarios, we can't ignore Git integration. I won't go too deep into it today, so I'll just cover essential aspects and that are relevant to this presentation. Second topic will be overview of the demo projects and workspace architecture. So to fully understand the environment, it's essential that I first present an overview and workspace architecture. Third thing is lifecycle management. Basically, here we will just go through what is the goal of today's session. Okay, so in our setup, we operate with 2 core environments or 2 stages, development and production. The development stage serves as space for building, testing, validation, and so on, while the production stage is a stable endpoint, used by stakeholders and end users. And finally, the main part of my presentation are various deployment options. After we are fully equipped with main concepts and tools, we'll dive into these 3 strategies I mentioned. So first one is deployment pipelines. Then we will go and have a look how we can use Fabric, REST API, and MS Spark utils, for example. And the third option for deployment is DevOps pipelines with newly introduced Fabric CI/CD package. Okay, so let's move to Git integration first. So Git was originally developed by Linus Torvalds back in, I think, 2005. And it's basically a version-controlled system, designed to handle everything software-related, basically. So its primary purpose is to track changes in source code over time, enabling history tracking, branching, collaboration, and so on. So basically, any piece of software or artifact that is text-based, that means that beneath it, it's code, okay, can be easily versioned and managed using Git. And now, if we look at the history of Microsoft data products, we can say that Microsoft Data Services supported, some sort of Git-based source control. If we have a look, I don't know, at the SQL projects, they had SQL Server data tools behind it. analysis services and integration services project were also structured in a way that made them compatible with Git repositories, because these were all project types were based, like for example the SQL. So .SQL is a plain text file. If we look at the analysis services, .beam is XML and so on. So meaning they are text, okay, and they could be easily versioned, diffed, and merged, let's say. However, Power BI was the exception for a long time in this atmosphere. So the PBIX file was a binary file for a long time, and it made it difficult to apply like standard Git workflows. You couldn't track changes. You made to, I don't know, individual visual measures, data model, and so on. And that made it impossible, you know, to integrate it with Git. So what happened in around 2021, I think, Microsoft introduced Power BI project file, which separated like the data model and Power BI report. Data model was basically in TMDL, is also now in TMDL format, so tabular model definition language structure, while the report layout is stored as a structured JSON. And that means that also Power BI artifacts can live in Git just like other code assets, enabling better collaboration, change tracking, deployment automation, and so on. So PBIX file was the last piece of a missing puzzle, and everything was ready to introduce Git integration into Microsoft Fabric. And honestly, when I saw Microsoft Fabric for the first time, that was my biggest plus of them all. So being able to integrate Git within Microsoft Fabric. Now, Microsoft Fabric, as said, supports native Git integration, and there are two providers that you can connect your workspace directly to. So currently it supports Azure DevOps and GitHub as Git providers, and once connected, your Fabric workspace can sync artifacts like reports, semantic models, notebooks, data pipelines, and so on. So here the important thing to understand is that most of the stuff in Microsoft Fabric is fundamentally code under the hood, okay? So pipelines, for example, can be represented as YAML files, which is basically a structured JSON. Notebooks are scripts, you know, by default. Lakehouse metadata is JSON-based. Semantic models, as said, are divided into the TMDL and JSON report structure. So that means that we can connect our Fabric workspace and put all of our code, you know, to some Git repository. So when we link our workspace to a Git, we can commit changes directly from within Microsoft Fabric. That means that every change you made to an artifact, whether it's editing a notebook, adjusting pipeline, I don't know, modifying a semantic model, can be tracked, committed, and versioned through Git. So to support team collaboration and safe deployments, let's say, Fabric also works well with Git branches. So a branch is essentially an isolated workspace where changes can be made without affecting like the main branch, so the production branch. For example, you can create a branch that's called feature something, and then you can here test, develop new KPIs while the main branch remains stable. And once your work is ready, there is like a concept that is called pull request. Pull request is basically just a formal proposal, you know, to merge your changes back from a feature branch into the main branch. And it's an opportunity, you know, for reviewing, discussion, and so on. So pull requests basically help ensure quality, consistency, and traceability across development and production environments. So now let's just jump to a quick Fabric demo just to discuss these three main concepts. So connection to the Git repository. So if I go to my Dev MBA Compute workspace, we will go through workspace structure and architecture later on. But here you're able to see that under the workspace settings, okay, I have here Git integration, okay? So, and if I click on it, I already connected my workspace to Azure DevOps. And here I can define which organization, which project, and which branch. And basically, when we do the sync for the first time, okay, all the Fabric items from here will be transferred to Azure DevOps. But now, when I have like all my items in Fabric DevOps, what I'm able to do is I'm able, directly in Fabric do the commits. Sorry, do the changes and commit the changes. But it's not a good idea that I do these changes directly on the develop branch, of course. And what I want to do is here under the source control, I can click on this button here. So this one, all right, and I can go and basically branch out to another workspace. And if I do this, I will just here write a branch name and a workspace name. So if I type here feature changes in notebook, for example, it will create me a new workspace. It will sync all the Fabric items from the main branch. And if I click on branch out, I will get this new workspace where I will do the changes that I need to do. So it takes some time, for the content to sync from Git to this workspace. So let's just wait a few seconds to populate. Okay, so now you can see that the status is syncing. And if I open one notebook, for example, MBA config, okay, you're able to see that I have some dummy cell here, SQL select one, which basically does nothing. I will delete this cell. Okay, so now my notebook is saved. I will go back to my feature branch. It will say to me here, okay, you have one change in the MB config. Then I will say, I don't know, fixed, removed dummy cell. I will commit it. Okay, so the commit is now going directly to this feature branch, change in notebook. Just wait a second. And once these changes are committed, I want to merge them back into my main branch. And if I click here on the current branch, feature changes in notebook, okay, let me just sign in. Okay, I'm able to see here that in this feature branch, okay, I did a commit and I'm able to create a pull request. So as said, pull request is just like a formal proposal to merge the changes from the feature branch back into the main branch. And if I click here, create a pull request, okay, I will keep the same title. I will create a pull request. And since I'm working alone, I will approve this work to myself and I will complete the merge. And when I complete the merge, okay, let's just go back and let's go to the dev MBA compute like this. Here, I have an option, you see, to update a change in that I make. Okay, so now you can see that here I have a merge conflict, okay, because I have one version of MB config that was basically edited directly in the main branch, and the other version that was modified via the feature branch. And I can just click here, accept incoming changes. Are you sure you want to overwrite an update? And click on merge and update. So basically, we're able to see that Git is perfectly able to also solve some merge conflicts, within the Fabric user interface. Now, these are some Git basics. Okay, I just wanted to show you the main functionalities we will be going through. So first one is branching out. Second one is making the changes and committing. And the third one is doing a pull request, to bring the changes back to the original workspace. Now, let's jump back to my presentation. And now let's have an overview of a demo project and workspace structure. So just one second. Okay, so For this session, my demo project is built around MBA games data. So it's basically a practical data set that helps demonstrate like real-world deployment and data lifecycle scenarios in Microsoft Fabric. So the data source I'm using is publicly available API called Bold-on-Lie API. And this API provides data for basketball games in NBA. I am pulling 4 different data sets. So basically, it's games data, games. The first one is data about games, who played who and what was the score. The second one is detailed games data, which holds data for statistics for each and every player that was in that game, as well regarding players and NBA teams. So let me just first go to the Fabric, and I will just show you my workspace structure. Okay, here you can see that I have workspaces that are named, MBA dash something, okay, and that they have an icon. This I used in my third scenario of Fabric CI/CD, but the same logic, the same business logic, let's say, same transformation, same reports can be found here also in this one. So dev MBA compute, dev MBA report, and if I scroll down a bit, so prot MBA compute, prot MBA report. I have that many workspaces because I want to show you different scenarios of deployment, and for each deployment scenario, I have my own workspace, let's say. But if I open the report, the MBA compute workspace, so this PPE here means that it's a pre-production acting as development, and prod, of course, is like the production area. Here we have multiple notebooks. Okay, for example, if I open this one, MB Games, what it does is that it takes data from, so first, of course, I get the API key directly from the Azure Key Vault, and then I just do some API calls, to my API endpoint, and I store all the responses into the Fabric Lakehouse. And at the end, what I do is I have these things scheduled with the orchestration notebook. Okay, so like this, and the end product of this is MBA report that basically looks like this. Okay, and it shows us, the MBA games data, daily scores on the left-hand side, and the current ranking. So this is about my demo app. But what I want to point out already is that basically to ensure like clarity, okay, my Fabric items are isolated based on their functional purpose, meaning that, for example, for compute, I have a separate workspace, and here in the compute workspace, there are only Fabric notebooks, Fabric pipelines, and data flows Gen 2. My second workspace is report workspace, so MBA report. Here in these workspaces, I isolate work in a way that I only have semantic models and Power BI reports. And in MBA storage, I only have like Fabric Lakehouses or Fabric DVH. This is important when we develop things. It's not only, just for the security perspective, to limit the user access, but it's important, to keep these things nice and tidy, so you always know, where you can find each artifact, let's say. But besides this, okay, my workspaces are not defined or are not divided on their primary purpose. They're also divided in a stage in a development. So you're able to see here that I have some kind of naming convention. Okay, so MBA compute PPE, meaning pre-production, and MBA compute prod, meaning production. And basically what I want to point out here is that the naming convention is extremely important, because with the help of Fabric REST API, for example, or MS Spark utils and so on, you can always get out like the name of the workspace, for example, that this notebook is executed in. Okay, and based on the last words after this dash, PPE or production can play a vital role in development. So I have a similar naming convention as well here. So def_mba_compute report storage, and on the other side, I also have like the same workspaces for the production Fabric items. And later in presentation, so I will show you how this naming convention and this structure can play like a vital role in the deployment process. So let's just go back to the presentation. Okay, so we are now here, and let's move to the next slide. So here, once again, is the visual representation of how my workspaces are structured. So storage, compute reports, storage holding DVH and Lakehouse, compute holding notebooks, pipelines, data flows, Gen 2, and the report workspaces that have, semantic models and Power BI reports within it. Now, for the first two scenarios, okay, it's important to understand that only dev workspace is attached to the Git repository, so to the Azure DevOps, while the production stage is not connected to Git at all. So the process of bringing the development Fabric items into the production in the first two cases, so with the Power BI deployment pipelines and with the use of the Fabric REST API, is taken care by the deployment pipelines at the end. And you will see how this works shortly. So, as said, to clearly identify and manage these workspaces, like the naming convention needs to be in place. Let's move forward. So now we will go through the lifecycle management in theory. So basically, challenges arise when changes in the development workspace are approved via a pull request. That's what we did earlier, and they need to be deployed to production. So, for example, Power BI reports, when in the development environment, they should point to a development lakehouse. So, but in a production environment, okay, they should point to a production lakehouse. And same goes for other Fabric items as well. So Fabric notebooks and Fabric pipelines in development environment should populate development lakehouse. And in the production environment, they should populate production lakehouse. So our main goal for today's presentation is that we ensure that Fabric items dynamically point to right artifact. And now, once we're equipped with all the theories, so Git, deployment theory, and so on, we're able to look at our deployment option that we have. And our first deployment option is deployment pipelines. So they're used for deploying changes across environments in Fabric. And we can use, as said, this native deployment pipelines feature. So deployment pipelines in Microsoft Fabric provide no-code experience for promoting content between stages. And each workspace is connected to a separate Fabric workspace. And this deployment pipeline helps you to compare, validate, and deploy content or Fabric items across them. So when deployment pipeline is set up, we can take care of deployment rules. And this is important aspect of the option A. So again, this is easy no-code experience, and this is a critical part of a clean dev to prod workflow. So let's just go back to the Fabric workspace, and let's just open Power BI deployment pipelines, which are here. And what I will do is I will just remove this pipeline, okay, and I will just set it up from the beginning. If I click here on the new pipeline, so the first step when using the deployment pipelines is, okay, of course, let's name this pipeline, so report pipeline. And what I need to do now is basically to attach my workspace to a stage in these deployment pipelines. So here by default, I have 3 stages, so development, test, and production. But in terms of making things a little bit more clear for this presentation, I will use only 2 stages, so development and production. And now what I can do is basically, so I'll just click on create and continue. I can assign, assign a workspace to a different stage in my deployment pipeline. So if I click here under development, I will attach, for example, I will attach, for example, this one, MBA report pre-production and MBA report production. And once I do this, okay, like this, now this will tell me or do me a comparison between production and development. And here I can see that I have some changes, in regards to development and production environment. And with one simple click, what I can do is I can simply click on deploy. And what it will do is it will simply push all the Fabric items that are supported, of course, by deployment pipelines from the development to the production workspace. But here, please keep in mind that when I do this, nothing really happens, in terms of the parameters itself, let's say. So what I can do is, once this is deployed, I can click on this icon here, which helps me define the deployment rules. And same as for the deployment pipelines, also the deployment rules use like easy to use user interface, no code. So it's really, you can get it quickly to be available. So it's basically a quick win. And here under the data source rules, okay, I can define like what is my, let's say, default lakehouse that I can connect to. And if I go a bit back, let's go to another deployment pipeline that I want to show you, is the compute pipeline. And same as goes for the, let's say, semantic models and MBA reports, okay? What I can do is for the Fabric notebooks, if I open one, for example, this one, MB orchestration, which is already deployed, if I go here, I can simply define what is default lakehouse. So basically in development environment is this lakehouse ID. So the lakehouse that is attached to the Fabric notebook in this workspace. But then when I do this deployment process, then it will transfer the same notebook, okay, without manually doing anything, basically just setting up a deployment rule here. It will transfer all the logic and attaching a different lakehouse. So this is extremely important to understand, because basically same notebook, okay, with same content will populate the development lakehouse in development environment and the production lakehouse in production environment. Okay, now let me jump back to my presentation again. So let's go here and let's look a little bit at the deployment rules. Let's go to the current slide. Here you can clearly see so which deployment rules are as of now supported in Microsoft Fabric. So we went through the semantic model deployment rules where we can change like the data source, parameter rule, and so on. For notebook, we can change the default lakehouse rule, but there are many more. So like we can do the same thing with data flows, semantic models, paginated reports, mirrored database, and so on. But yeah, so that's it regarding deployment rules. So if we look at the pros and cons of option A, okay, it's easy to navigate. It's a no-code experience, okay, and it's a really fast setup, like for small and medium-sized projects. Cons of this solution are that it's hard to handle in enterprise environment, because for every Fabric item you have, you need to manually define this rule by hand. There, as far as I know, there is no Fabric REST API that that enables this. Okay. So you have to do it hand by hand for every fabric item, and you can easily miss one of those. But on the other hand, okay, at the last FabCon in Vegas, they introduced like the workspace variables. So maybe you can help yourself out with this. But as said, this is it, and not all items, of course, support the deployment rules. Okay, one of those items that do not support this kind of rules is Fabric Pipeline, which is on top of that list because they are, you know, as a main orchestrator within Fabric environment. This is a big minus, let's say, and the other minus there is that there is no real connection with Git. There is no hard connection with Git, basically, because you can do your changes in development environment, and you don't have to commit them to the Azure DevOps, and still, you know, the deployment pipeline will transfer all the content from development environment to the production environment. So this is also one drawback of this solution. But the biggest one of them all is that, of course, it's hard to handle this in enterprise environment. For example, if we just go back to the workspace itself. So here in the Dev MBA Compute, you can see that I have, I don't know, by rule of thumb, let's say 10 plus notebooks, okay, and one pipeline. Now imagine, so this is one small project. Imagine being in an enterprise environment with, I don't know, 1,000 employees plus, where you have, I don't know, 100 notebooks and so on. So clicking on each and every body of them to apply a deployment rule is hard. But maybe one tip is that if you do your orchestration via Fabric notebooks with DAG, okay, what you can do is you can use in the arguments this thing here. So use root default lakehouse, okay, and this argument here will take the default lakehouse of the orchestrator notebook, and it will execute this, you know, in context of the default lakehouse. So this one, and even if, I don't know, this MB active players notebook is attached to a different lakehouse, okay, this parameter here, as said, will override that rule and use whatever the default lakehouse for orchestration notebook is. So basically, this is one quick tip that can solve this problem. But as said, it's still, we can do a bit better. Let me go back to the presentation. And now the second option here is smart use of the ABFSS pass and REST API. So as said, deployment rules can get messy and hard to handle in enterprise scale environment. And we want something that is not no code based, but it's rather, let's say, a low code based. Okay. So, and what I did is, and let me just jump back directly through to the demo again. What I did is that you can go, if we go to the compute workspace, okay, and here I have the MB config notebook. If I open this notebook holds the dictionary, okay, and showing me what is the lakehouse endpoint for development environment, so this one, and what is the lakehouse endpoint for production environment, this one. And if we call this script at the beginning of every notebook, we get this dictionary. And now let me just go to one of the existing scripts. So this one, MB teams without deployment rule. Okay. Here I call this script to get a dictionary. And with the smart use of either, let's say, Senpai library or Fabric REST API or MS Spark utils, I can find out, you know, sorry, with this function here, in which workspace I am executing this notebook from. And once I get like the workspace name, and in collaboration with smart naming convention, okay, I can see, okay, is it this either a dev or production workspace? And based on this output here, because I am looking at the first reoccurrence, so what is written before the this sign here, okay, this is dev, okay, and with this dev variable, I'm going to my dictionary, and if I look to my dictionary now, I'm able to see to which lakehouse or to which endpoint should I sync the data. So what is my destination? And then I just built this ABFSS path. This is something that notebooks like to work with. And I'm able to use this ABFSS path, in the future cells. So if I go down, instead of saving this as a table, because I don't have I don't have a lakehouse attached to my notebook, I can simply save this table, with my ABFSS path. And the important thing here to know is that, okay, we are still using the deployment rules to get data from development to production, in this case, notebooks, okay? But we aren't using any deployment rules, and in the scenario where we use notebooks and lakehouse in combination, this is like a perfect low-code solution for this scenario. As I said, in this scenario, I don't attach lakehouse to my notebook, so we have a little bit of a drawback, using Spark SQL. But I just like to mention that there are some workarounds where you can create a temp view and work on this, with the basic SQL syntax as well. So this is one example, okay? This is within notebooks with the smart use of the ABFSS path, but we can do the same with pipelines, okay? And if I go to this PL Teams API, what I can do here is basically similar logic, okay? So this is one pipeline that copies, the API response of my NBA games data to the correct endpoint. And what I can do at the beginning is, so this part here, okay, I can simply call a Fabric API, and this function here, okay, will return me so this will return me the current workspace ID. And based on this, once again, I can say, okay, is based on its name, is this there for production? And then I will just list all the workspaces, filter out the storage workspaces, and basically get the correct lakehouse information. So to which lakehouse should I copy the data to? And here, the output of this activity here is lakehouse ID, the workspace ID of the lakehouse, and the SQL endpoint. So when I have this, I can just simply imply this to a destination as my pipeline variable. And as said, again, this PL Teams API will work is the same in development and production. No deployment rule needed, okay? But it will sync the data to a different destination because of this procedure at the beginning. So let's move back to our presentation. So we did a demo of option B, and now we're here. So what are pros and cons of the option B? So solution is easy to maintain because actually you need to keep one dictionary that I showed you under the MB config, and there is no need to define deployment rules in the user interface. So if we just keep in mind that for every notebook or for every pipeline, we need to do some kind of procedure beforehand, then we're completely fine. But on the other hand, we have some cons, and one con is that this is a limited use case, let's say, because I showed you the notebook plus lakehouse scenario, okay? And notebooks work well, only with data sources like, I don't know, other lake houses, OneLake, Data Lake, JDBC, REST APIs, but let's say not for it, it doesn't work well for the on-prem databases, so we need to find a solution for this as well. And the second con there is that dynamic content can be set only for lakehouse and warehouse connection. This changed a bit at the last FabCon because we can also put variables for other data sources in the copy activity. So it will be interesting to also have a look at this, if it's possible, to define a pipeline in a way that they also, I don't know, for example, read from a different endpoints, let's say, based on the variable in the pipeline. So this brings us to the last point of the presentation, and this is the option C, which is the DevOps pipelines with Fabric CI/CD library. So this is like the main part of my presentation. So as said, low-code solution still isn't fully flexible when it comes to deployment. We have some limited use cases where we can apply this to. But at the beginning of 2025, the Microsoft engineering team that is led by Jacob Knightley introduced Fabric CI/CD. So Fabric CI/CD is basically a Python library, and this Python library can be introduced, in the Azure DevOps pipelines as well. So let me just go directly back to my demo, and I will show you how it works. So as said, with first two options, we were relying on the deployment pipelines, to get data from development to production. And here, the important thing to understand is that we won't be using these deployment pipelines anymore. We will be solely relying on the Azure DevOps. So let's go directly to the demo cases. Okay, and as I said, so these ones that have like the MBA icon, okay, are used with the Fabric CI/CD. So how this works? Basically, when I do my work on a pre-production or development environment, I do the initial sync via the Git integration feature that Fabric offers to Azure DevOps. At that moment, I completely connect the Git here in the workspace, and Fabric CI/CD will do all the rest. And now let's have a look how Fabric CI/CD actually works. So if I go to the DevOps now, you can see here that under the deploy subfolder, I have three different Python scripts, okay? One is for the compute workspaces, one is for the report workspaces, and one is for the storage workspaces. And let's open, for example, this one, MBA storage .py. And here, what I do is I already have app registration, and basically here in first step, I just, call the client ID, client secret tenant ID, which is, secretly stored within the deployment pipeline. Here, I get a token. And of course, this app registration is admin, okay, in both, pre-production and production workspace. And how Fabric CI/CD works is that it goes to the parameter file called parameter YAML, okay? And if I open this file, here, basically, it's a simple find replace logic. So what I do here is that in pre-production environment, okay, my Power BI report is connected to the development lakehouse or pre-production lakehouse, but the production report is connected to the production lakehouse. So basically, I have two different endpoints that I connect my semantic model to. And what this script does is, once again, first it checks, which branch was affected. If it was pre-production branch or production branch. Here in this step, I simply define where the Fabric CI/CD should deploy the content. Okay, I look for the parameter YAML file within the MBA storage. Okay, and basically then the Python function takes care of the rest. So basically this is a definition that will deploy the Fabric items to this workspace ID using the, so the environment here is, where is it? 1 second. So it will use in the find replace this keyword. So if I go back to the parameter YAML file, okay, you see here I have different endpoints for PPE and production. And once again, let me just go back to this one. It will just do a simple deploy. Here, one thing to keep in mind is that Fabric CI/CD works in a way that it always does a full deploy and does not care about commit diffs and so on. So in the background, Fabric CI/CD just publishes everything that is within this workspace, okay, within this folder, and it will unpublish items that are not presented within folder itself. So these are the Python scripts, but these Python scripts are of course triggered by DevOps pipeline, and let's have a look at the pipeline as well. So basically it's triggered when PPE or production branch is affected, meaning that I have some div there, okay, and it will only, of course, deploy things under the workspace folder. So let me just go back a bit to say something. So in this repo, okay, I have all my Fabric items within workspace folder. So this one, MBA compute, is compute workspace, MBA report is report workspace, and MBA storage is storage workspace, meaning lakehouses, data warehouses, and so on. In the .deploy folder, I hold my Python scripts that are basically triggered with the Azure pipeline. Okay, so here is the whole definition that I will put also on my Git account, and I have some twerks here. Okay, for example, here I also check, let's say, at the end, to check which files changed based on the last commit. So because I have all my workspaces within one DevOps repo, okay, I don't want to deploy report workspace, for example, if there were no changes in the report workspace. So I only deployed those that changed based on the last commit. So we have a look at the diffs and do the deployment of what's needed. So to sum it up, okay, as said, these Fabric items are not connected to the Git, you know, within the, sorry, I'll just show you another one. So are not connected to the Git from the Fabric UI. So you can see here that it's not connected to the Git, okay? Okay, now let's go to the MBA report PPE workspace, and let's do one commit from this, and let's move the change from the PPE to production. And what I now want to do is, let me go back to the branches. And here within branches, what I will do is I will create a new branch within Azure DevOps, okay? And let's call it feature report change. I'll click on create. And now I will go to Power BI. I will create a new workspace, and I will call this new workspace feature report change. I will connect this feature workspace to my feature branch. So data consulting, MBA Fabric, this repo, the branch I just created, and here git folder. Okay, here I need to be specific and say, okay, I want to do change workspace, in workspace MBA report, because my Fabric items related to the report are in this workspace, or in this folder in the DevOps. Sorry. If I click on connect and sync, let's just wait a second. To populate, and I will do just one minor change on the report directly here. So MBA report, okay, too many items open, so let's close this and this. What I will do now is I will just edit this, and I will just put this timestamp right here. So basically this is like the last refresh date. So instead of being here on the top, I will put it here. Okay, I will click on reading view to save my changes. And let's go back to the feature bench. Of course, you know the lection from the first part of my presentation. Let's do first a commit. So changed commit. Let's go now directly to the DevOps to here. And what I will do now is, let me just check one thing, because I think that at the beginning of presentation, when I was showing the Power BI deployment pipelines, I accidentally mapped this to a report pipeline here. So one second, BA report PPE. Let's just make sure that this is not, connected to Git. It isn't, okay? So the MBA report PPE is not connected to Git. So what I will do now is I will create a pull request, change data label, okay, like this, create a pull request. And now let's complete this merge like this. And now let me just go here to the pipelines. And here you can see that the DevOps pipeline started working. Let's just go within it. So I did this merge, change data label. Let's go directly there. And here I can see that I'm executing the deployment pipeline. So the DevOps deployment pipeline. Here I checked so the files that changed in the last commit. So this is it. Okay. And let me just go back really quick. And this, as said, is executing a service principal, which is admin in both of my workspaces, pre-production and production. Here it validates the parameter file, okay, meaning that it will show the in the PPE, it will show the in the pre-production environment, sorry, it will connect to the pre-production lakehouse, okay, but in production it will connect to production lakehouse. And we can see now, that this change is done. And even though here I'm not connected in any way to Git repository, if I refresh this, okay, and open this, I can see that this label here is at the right place. If I go now to the production workspace, since I haven't do a pull request from pre-production to production, I can still see the label here on top. Sorry, so let me try something. Okay. So what I need to do now is basically I need to do a pull request from PPE to production to merge the changes here to the MBA report production. So one thing I want to point out here is that, okay, we talked about the parameter file where I changed the lakehouse endpoint of the semantic model. This can be applied. So the parameter file can be applied to any Fabric item you can imagine that is text-based. So for example, also for the connection within the copy activities, okay, in the pre-production environment, I can do a copy activity from development SQL server on-prem, for example, but in production, I can do a copy activity from production server. Because if we look at the YAML file and copy activity, okay, basically There it is stated only the connection ID, you know, from the copy from, copy to job. And it's really easy, you know, to also get over that issue with Fabric CI CD. So let me go back to the presentation now. And let's talk about the cons of the option C. So it's flexible solution that is based on item definition with find replace logic. We went through that. As I said, now it can switch between connection, dev, or prod. And it's really not hard to set this up. I don't come from the DevOps background, and I was able to get it up and running. So the only con that I see here is that it always deploys whole Azure repo. So I already said that no diffs are taken into the account. So whatever we have in this folder will be published to the workspace. And yeah, that's basically the only con I see here. So in summary, we went through 3 different deployment scenarios that were presented. And now the question is which one to choose. So we have deployment pipelines that offer us easy UI experience and allows everybody to adapt deployment scenario. The second was the smart use of Fabric APIs and MS Spark utils. This is basically excellent low-code option if teams are mostly working with notebook plus Lakehouse architecture. And the third option was the flexible solution with Fabric CI/CD, and that is really for the teams that are mature enough to deal with the DevOps pipelines. So my answer, which deployment scenario to use, is relying on the maturity of your data team. Okay, so I think we are on time. This brings us, you know, at the end of the presentation. I'm grateful for your time. Thanks for the opportunity for having me, and special thanks to my mentor, Marisol, who was always there for me regarding technical questions, you know, how to present this, how to prepare presentation and so on. So I'm really thankful for her time. Okay. Thank you.